Think of a traditional SQL database like a rigid filing cabinet where every folder must have the exact same forms. NoSQL, or not only SQL, is more like a digital backpack. You can toss in different items without needing a predefined template for every single pocket. SQL databases scale vertically, like stacking more floors onto a single building. NoSQL scales horizontally, like adding more houses to a growing neighborhood, allowing you to distribute data across many servers easily. The power of NoSQL lies in schema flexibility. Unlike a spreadsheet that breaks if you add a new column, NoSQL documents act like independent envelopes that can hold unique information without requiring a global change. We start by defining a constant variable named user profile. In NoSQL, this represents a single document, which is the fundamental unit of data storage. Inside, we assign a unique ID. Every NoSQL document typically requires a unique identifier to ensure it can be retrieved quickly from the database. Next, we add a simple name field. Notice how we are building a key value pair, which is the core building block of NoSQL data models. NoSQL allows for nested structures. Here we add a preferences object. This nesting keeps related data together, avoiding the need for complex joins used in SQL. Inside the preferences, we define specific settings. Because this is a document, we can add or remove these fields later without restructuring the entire database. Finally, we include an array for tags. NoSQL databases handle lists and unstructured data natively, making them perfect for high-velocity, evolving content. We begin by updating our package list and installing two essential tools, JQ for processing JSON data and SQLite 3 for managing relational databases. These utilities are staples in any Linux environment for handling structured information, whether it is stored in flat files or within a robust database engine. The package manager resolves dependencies, automatically fetching and installing the necessary libraries like libjq and libonig. This ensures that the JQ utility has the required runtime environment to process JSON data efficiently. By managing these binaries, the system maintains a stable foundation for our upcoming data manipulation tasks. Now, we create a simple JSON file named user.json. By using the echo command and redirecting the output, we define a record containing an ID and a name. This demonstrates how easily we can generate structured data directly from the command line for later processing. Using the JQ utility, we parse and display the contents of our JSON file. The dot filter tells JQ to output the entire object, which it formats cleanly for readability. This is a powerful way to inspect and manipulate complex data structures without needing a full-blown programming language. Next, we transition to a relational approach using an in-memory SQLite database. We define a fixed schema with a table for users, insert a record for Bob, and then query the table. This highlights the structured, rigid nature of SQL, where every row must adhere to a predefined set of columns. To summarize, SQL provides a fixed schema table structure, ensuring data consistency and integrity. In contrast, NoSQL documents like our JSON record offer a flexible schema, allowing for dynamic data structures. Both approaches serve different needs depending on whether your data requires strict organization or rapid, adaptable storage. Notice how we use the memory flag to create a transient database that exists only in RAM. We then execute a semicolon-delimited string of SQL commands. By defining types like int and text, we enforce strict data integrity before retrieving our record with the select statement.